Right, hello and welcome back. So I've just restarted the stream because of video problems in the last one, not showing the correct monitor. So quick recap of where we are. In my last stream we looked at implementing lambdas using in my scheme compiler. We started off by, in the binder, recognizing the lambda expressions and creating a special form for the lambdas. And then we went on to work in the compiler to emit the lambdas, which we did by first creating a emit named lambda, which creates a new method definition, writes out the body of that method, and emit lambda, which recognizes your lambda special forms, gives them all unique names, and then emits those. So the plan for today's stream is to look at improving the recognition of lambda expressions with our bind lambda, but at the moment we don't recognize all of the different types of formal parameters. And the second thing to work on is to actually properly emit the lambda method body with our formal parameter list, and then look at making lambdas something that is actually an object instance rather than just null. So just to recap what I have been going over, so the first thing is I've added this new definition of BoundFormals. So BoundFormals has got three different variants. Simple, which is the simple bound formal, where you bind all of the parameters to the ID of the lambda expression. List, which is if you want to provide an exact list of parameters like A, B, and C and say that your lambda should only be callable with three things. And dotted list is when you can specify a certain number of parameters like A, B, dot, and then C, which will be bound to any extra parameters that you might apply that function with. So if you call that, you'd have to call it with at least two parameters, but if you gave it two, that'd be fine. You'd get an empty list as C. If you gave it three, you'd get a list containing the third parameter as C, and so on if you add more parameters. So the first bit of work is down here in BoundFormals. So we've got formals, which is our AST node that we're recognizing here for the parameters. So this could be just a single ident, which we're binding with bind as a BoundFormals.simple, creating a bound formal just for that ID. The other case is if you have a list. So I'm just going to change this error expression to be unrecognized. So in the case where we have a list of formals, the plan here is to start off with a list that just we'll use the list.map. We'll start off with an empty list of all of the formal parameters before the dot, and an option where we can store the parameter we saw after the dot. And then we'll just do a list.map or a list.fold, where we walk through the list and add to our bound formal. If we see a dot, we will store that, and then we will store the last parameter as a sum value if we actually see one. And then the plan is at the end, once we've got our list and our tuple containing our list and our optional parameter after the dot, we can switch on that and decide whether or not we want to return a BoundFormals.list or a BoundFormals.dotted list. So I'm going to start off with a list.map, and we will list.fold. And then we will give it formals. And here I'm just going to return BoundFormals dot list and give it an empty list so that at least type checks for the time being. So BoundFormals list. Just waiting for the compiler to catch up a little bit here. It's quite nice weather in the UK at the moment, and my laptop is struggling with the heat and OBS all at once. So here, list.fold. What is going wrong? Expression was expected to type BoundFormals. That one must be out of date. But it has type A list. I guess this is the wrong way around. Hopefully, well, usually I'd rely on intelligence here. I don't program in F# that much. But it's not really working very well for me at the moment. So if you've got a list, what does list.fold, which way does it take its arguments? List.fold takes the function, which takes an accumulator and an element, and returns the new accumulator. Give it the base accumulator and a list. So our BoundFormals here takes an accumulator and an element and returns the new accumulator. And then when we do the BoundFormals, accumulation of formals, bound ends up being okay. That's good. So we'll start off here with let's move this inside our BoundFormals. So we want to start off with the empty list, false, and none. And then in here, we first match, well, let's give this a type annotation. So the first thing to do is to switch on the second element. Yeah, we could just destructure the tuple and use them. Yes, that should be list bool. Sometimes I forget that I'm not in Rust. formals. If we have seen the dot, yeah, so if we've seen the dot, then we want to match the current formal if it is it's an ID, then we return a new tuple with formals true and bound formal of that ID. For anything else, we end up with failing. If the dot hasn't been seen yet, we will match the formal with, it could either be a dot, in which case we return the same as the formals, true, because we have seen the dot now, and bound, must be some and none, because we haven't yet seen anything after the dot. Could be just a plain ID. If it's a plain ID, then we will prepend the bound formal of that ID to our formals false none. And if it's anything that isn't an ID, which is called ident, if it's anything that isn't an ID, then we just want to fail. So that largely looks like it would work. Let's go and see if it does. So at the moment, recognizing the formals is all we need to do. I don't think we use them anywhere in the compiler, but I'm just going to check. Looks like we do. Looks like there is a failure here somewhere. Ah, yes. So we're expecting to pass in bound formals here. says yes. We'll recognize the question here is, what do we want script body to take? Previously it took no arguments, and I think we still do want it to take no arguments. So let's create a new body params for this. I'll just use the empty list. Really wish that my laptop wasn't suffering quite as much here. So if all goes well here, we should be able to run this and type in some lambda expressions, and hopefully we will be able to use a few different forms of formal parameter list. We're still not going to do anything with those formal parameters yet, but it's probably a good idea to at least check that it does work. So let's run it. Okay, so here we go. Let's check that simple things still work. That's good. An empty list is still an empty list. If we do lambda x, which returns 100, we end up with null. If we do lambda and then give it an empty list when it returns 100, that's now returns null as well. That's good. So that means that we're at least recognizing the lambda and parsing it properly. So let's try a lambda which takes 3 parameters, A, B, and C, and returns something else. That's at least being recognized. A and B, and then a dot, and then C, and that's all good. No, it's not good, because we don't recognize a dot as being an identifier. We recognize it as being, well, I'm trying to think where you would use the dot. I'm not sure that you would ever use a dot if you weren't using it in a dotted list. If that's the case, I think we can probably have a new symbol, a new AST node type for a dot. Let's try this with a kind of lambda that doesn't have a valid parameter list. So let's try running it to a constant. Yeah. So I expected an ID or a dot in formals, but we didn't get one. Good. So it looks like a dot is not an ID. So the place we should start for this is we should head over to the syntax, which is where we recognize all of these. And this is where we've got our different types of AST node. So we don't really need to keep any kind of information about just a dot. So let's just have dot. And now, obviously, we should probably have a test that makes sure that we actually pass one of these. So if we head on over and go to the syntax tests, parse atoms sounds like a good place to put it. Dot read single of a dot. Now if we run that test, we should expect it to fail. Back over here, we've got parse string, parse bool. Where are they all being used? Parse atom. So I think we want a parse dot. Parse dot is just going to say that so I'm going to parser that there's an operator for this, isn't there? So if we match that, I think it is that. No. I'm going to have a look at parsing library and look at returning something. Yeah, it is shift. I was reading that wrong. Shift %. Yeah, parse the returns an AST node and takes no state. Good. So now if we run that test, it should pass. Being warned about incomplete pattern matching. Doesn't sound good. We need to get a lot better at error reporting in the compiler. So at the moment, if we fail here, for example, we'll end up with an exception that says unexpected dot, which if you're debugging it, you can at least work out what's going on. But if you're not running the code under a debugger, it could be quite tricky if you're just told, oh, you've got a dot somewhere and I wasn't expecting it. And then when we recognize the formals, we want to say if it was a dot. Let's try running this again. So hopefully we'll be able to use dots now. One thing we're not yet doing is stopping you from using a dot and then more than one identifier. I'm not sure if that's something want to try and tackle next. So what we'd have to do there is if we have seen the dot and we have any state stored in after dot, then throw. The question is, do we want to do it here on line 101, or would we want to wait and do it after we've recognized that it is or isn't an ident? Not sure from an error reporting point of view which one would be better. So simple lambda works. Yeah, this works. There's nothing here to stop me from doing a b.cd. We recognize that, and the way that our parsing code is working, we would end up with just overwriting after dot to be a new bound formal. So we'd end up binding the remainder of the list to D, and you'd never be able to do anything with C. So I think we'll handle that case. So if the after dot is sum, then we can fail with only expect a single ID after dot. So if this works, then I think we've checked off the first checkbox for today's stream, which is to recognize the different variations of formal parameters. So lambda x works, lambda with some list of parameters works, lambda b.c works. Ooh, reference to undefined symbol. I shouldn't have done that. Lambda a b, that's actually not an a, but doesn't really matter. We recognize, but lambda a b dot cd, and we end up with an exception because we were expecting a single ID after the dot, which is good. So I'm going to check that off. That is the first part of today's work completed. So let's commit it. So we're recognizing with BoundFormals. recognize it, defaulting out BoundFormals in the compiler, recognizing dots, and adding a test for dots. I think it's probably also worth adding a few new lambda definitions. Running tests again. We'll need to go to the spec tests and tell them to generate a new set of snapshots. So the way that snapshot testing works is, which is what we're using here for the spec tests, is that we have a folder full of scheme files, and we go through and find them at runtime when we run the tests, and then we execute a bunch of XUnit tests for each one. And for the simple parse test, it just parses the file and checks that the parse result matches the snapshot. So there is a snapshot stored next to it, and this is effectively just the serialized JSON representation of the parse result. We use that parse result, compare it against the one that we've just got from calling parse file, and if they're the same, the test passes. If they're not the same, the test fails. So in this case, we failed one test because although it compiles and runs and produces the same output, it does not parse to the same thing. So we use this attribute up here to tell the tests, no, it's okay, go and update your snapshot, rather than consider the tests failing. This way, when we have this uncommented, it's because we're updating our tests, because we've changed something, we expect it to be different. If we have it commented out, tests will fail if we change something that changes what we parse or execute things as. So that's all good. And now we've got this parse lambda diff, which adds an extra form where we define the first lambda and then the second lambda. Okay, so we've added support for list patterns to our lambda expressions. So the next thing is to introduce bindings for all of those into our environment properly. So at the moment, when we bind in the binder, we have I just accidentally committed a whole load of stuff I shouldn't have created. Oh no, yeah, we return the lambda expression. Okay, so this is what happens. Yeah, so we recognize our formal parameter list, and then we return a bound expression.lambda for that list of formals. But what we don't do is go through that list of formals and add them into our new context. So we've created a new binder context. So what we need to do is have a look at what formals we've got and add definitions for each one of them. So, well, before we start, let's just run it again and prove why we need to do that. So before, when I did a lambda ABC and then tried to have the lambda return a value that was passed in as a parameter, threw an exception, and that was because of this, because we're not introducing definitions into the new lambdas environment for the parameters to the lambda. So lambda ABC is fine if we return something like that we've already know the value for. But if we do lambda of A, B, and C, and actually try and use one of these parameters, like A, we end up with an exception because we've referenced an undefined symbol. So we need to go through and make sure that they aren't undefined symbols. So we could have one of a few different types of formals that we've just passed. So let's match it. If it is a BoundFormals simple, with a simple formal, we'll call that ID, then we just need to do context dot binding, yes, ID, and add binding is also going to need binder context. What's add binding context ID? Type binder context. Is it going to be binder context dot scope? No. Binder context to add binding. Ah, yes, it's binder context to add binding. we could also have a BoundFormals.list with the list of formals. If we have that, we want to do list dot for all binding context to add binding context. So we'll just go over and add a binding for everything. We don't actually care about the storage refs that add binding is adding and giving back to us. And we've got the dotted list. So the dotted list has the list of formals and the extra formal. And again, we're going to do list.map. I think it's effectively just take that, do that, and then also do that. But we'll call it D. Yes. So we've got these lists of bound formals, but when we're adding them to the binder context, we'd rather add them as string for the ID. We're not really gaining a huge amount right now from having this bound formal type, so could just remove it. Because initially it was there because we wanted something nicer to put in our bound expression to tell people that this was a bound formal argument. But now we have the bound formals type. We already know that the things inside them are bound formal arguments. So we just need to get rid of all of this round tripping of the type. Bound formals. So hopefully this compiles, and then I think that should be all we need to get those formal parameters that we've passed into our binder context. So let's just try a simple lambda for the time being. So a simple lambda works, but what happens if you have a lambda that takes a list of arguments and just returns that list? We get reference to undefined symbol. That's, well, it's a shame really, because why? Well, let's go debug it. So we've got a lambda and we're doing some binding. Let's put a breakpoint on here where we've got our BoundFormals back. Run it again. And see where we end up. Lambda XX again. So here we are. We've got our formals. We've got our BoundFormals, which is a single item of ID. It's a simple BoundFormal. We've got our new binder context. Oh, I see where the problem is. So if we step over here, we see that binder context add binding is adding the binding to the main context, which is at this point context is the context of the parent scope. So if we add the binding here, we'll end up with X in scope outside the lambda rather than inside the lambda, which is exactly the opposite of what we wanted to do. So do we need, I mean, the simple quick fix here is to change context here to lambda context. So we add the bindings in. But I'm not sure that we can leave it like that. I'm not sure whether or not just switching that to context so that you can no longer see the parent context would be better to stop the similar kind of problem in the future, but for the time being, that'll work. These are the only places where we actually add things to that context, and then we call binding context. So now, hopefully, those bindings should be in the lambdas context, and when we call bind on the body, we should end up with no exceptions. Does that make sense? Running low on water here, and by running low I mean I'm completely out of water. So fingers crossed this works. We can check off another item from our stream to-do list, take a break and come back for more lambdas later. Lambda XX, get our BoundFormals, and then if we step over that, we add the binding to the lambda context. Yes, that scope has a binding for X. Bound body is going to be a reference to X, and then that's it. We end up with our lambda. Trust it now. Ah, I should not have trusted it. We are not adding a reference to the symbol D. Why did that happen? So it could be that we're not binding that formal correctly. So let's run that again and find out why we end up without being able to reference D. What I'm going to do is try here just with a simple lambda that has a single list and see if we end up with the same problem. To work out if this is a problem with lists or dotted lists or both of them. So we add binding for every single one of them. So what does our lambda context contain now? It's got nothing in it. Why? List.map is it because we are ignoring that. I think we want to list I'm confused that though, because the first time we did it, it was with the dotted parameter, and the dotted parameter binder context add binding should have added it here. So we need to find out why. We can do list dot. It's not a predicate. Treat it as a sequence. I know we can just use a for each loop. Maybe that would just be the best way to do this in F#, but it doesn't feel very functional. Is list.map lazy? Let's just do it with a for each loop. For ref in formals, do binding context add binding. So this is saying this type storage set ref. Yeah, so let's ignore that. That should work. And then for each one of our formals, and our dotted, we're going to add the formal, and then we're going to add the dotted. So lambda a. What's going wrong here? Let's bind our formals. BoundFormals is an empty list. That'll do it. So we've got our bound formals here, and we don't actually do anything with them. So what we need to do here is we've got our bound formals list. So we need to say if bound dot so we take our formals, saw dot dotted. If we saw a dot match dotted, if it's some D, return bound formals dotted list with formals and D. If it's not, so this is the case where we've seen a dot, but we haven't actually seen anything after the dot. We're going to do fail so a dot and no ID in our formals. What is the problem here with BoundFormals dotted list? It could be something that's going to go away. Then if we didn't, see a dot, then we just want to return BoundFormals.list with our formals that we actually did see. So hopefully when this compiles, we'll try that again, and we'll see whether or not we end up with the right formals when we provide a list and when we provide a dotted list pattern. So I think that has failed to launch it properly. Yeah. Let's just go and run it straight from the command line, because I don't want to wait for another build. We'll just hope it all works. So lambda z and z returns a lambda z dot df, apparently returns another lambda, so that works. And if I do lambda z dot nothing and then try return z, yeah, lambda z dot nothing, try and return z, we end up with an error because we saw a dot, but we didn't see an ID. So the problem was that we loop through, we see our list of formals, we see the dot, but we've left the BoundFormals state in effectively an invalid place. So when we come to try and unpack it, and we see that we're after a dot, well, we've seen a dot, but there's nothing after the dot. Sorry, another way around. Down here, if we've seen a dot, but there's nothing in the dot, we raise an exception. So I think that's the formal parameters properly parsed, and we have introduced bindings for them all. Let's just try with a few other examples and then we'll wrap up the stream. So let's do A, B, C, D, and I do A. It works. And A, B, C, D, I can even use D. Yeah. With a dot, I can use something from before the dot. And we already know that we can use something after the dot. And we can also just bind the whole lot to a single expression. Right, so that is introducing bindings into the environment working. So let's commit it. So we got rid of our bound formal because we got rid of our bound formal because it wasn't really helping us, and that's what most of this change was. We've fixed up the bug where we weren't actually properly returning a list of formals or dotted. If we saw a list used as a formal parameter, and then when we have bound our formals, we switch over them and introduce bindings into the Lambda context. Good. Into the Lambda context for each formal identifier used. So Lambda bodies can refer to their arguments. Wonderful. Right, so that's just about it for the stream this morning. We've gone through and sorted out binding of the formal parameter list. So we recognize the different kinds of parameter lists that Scheme supports, and we've introduced bindings for those into the child context that's used when we bind a Lambda body. And that means that Lambdas can at least reference the identifiers that are used as their parameters. We haven't yet tackled things like actually distinguishing between local variables and global variables and captures and things like that. So that's for a later date. But I'm going to take a break now, and then maybe this afternoon have a look at making Lambdas callable and actually unpacking all of the arguments that are passed in when you try and apply a function, so that way you can actually call Lambdas properly. Right. So thanks for watching. See you next time.